Okay, so we're doing chapter 9, problem 47. So it says we drop a 12-gram ball from a height 1.5 meters, and it bounces up to half that height, 0.75 meters. What was the total impulse on the ball when it hit the floor? Okay, well, we know impulse is just the change in momentum, so that's what we're trying to find. So if we call upwards in the positive direction, and the downwards in the negative direction, such that the final velocity is positive, the initial velocity is negative. Talking about before and after the collision. So to figure out what the speed is when right before the collision, we need to figure out this, right? And we also need to figure out the speed after the collision. Well, we use energy conservation for that. So we know that the kinetic energy at the bottom equals the potential energy at the top. So this just tells us 1/2 mvv squared equals mgh. Okay, so if we rearrange that, we see that v at the bottom now is negative, because we defined this as negative, square root of 2gh. Okay, well, similarly, we're going to have the same thing for VA. So we're going to have 1/2 mv after squared equals mgh prime, which is the height after the collision that it reaches. So that means this is also going to be similar. It's not going to be negative now because this is going upwards, which we defined as positive. So this is 2gh prime. Okay, so now the impulse we can just calculate delta p. So this is m delta v, or m times v after minus v before. Okay, so this becomes m times 2gh prime plus 2gh. Cool. So let's just find out what this is. So this becomes m 2g times square root of h prime minus square root of h, or plus, sorry, not plus. So we have 0.012 kilograms times square root of 2 times 9.8 meters per second squared times square root of 0.75 plus the square root of 1.5. Okay, so if we plug that in our calculator, we get a impulse of 0.11 kilogram meters per second. And which direction is this? Well, the change in momentum means we have more momentum coming down than we do coming up. So that means the impulse is directed upwards. Awesome.